Installing solar panels. Questions. Why is solar better than electricity? How many people use solar versus how many don't? How much potential energy, money and carbon emissions could be saved, thus reduced? How does solar work? Energy consumption, carbon emissions, before and after comparison, cost before and after comparison. Seasons, is summer better due to sunshine? Summer, autumn, winter and spring. The amount, the size of the roof and the size of the solar panel. Optimal position, north, south, east, west. Angle of the panel, angle of the roof. Calculations. Cost to install, energy a family uses. Average, how many solar panels do you need to produce this amount? Money saved, energy saved. Average household, people, how many panels can you fit on a roof? Convert the sun's energy into electricity. A control device changes the electricity, enabling it to power electrical items. The electricity then passes through a breaker box to outlets within the building. Items such as a refrigerator and lamp can plug into outlets for power. Fossil fuels must be located, excavated and transported before they can be used. These processes are invasive and detrimental to the land through side effects such as erosion and ecological and geological instability. The deposit or well is depleted. Energy from the sun is infinite and free, and it can be harnessed or turned into power anywhere a solar panel can be mounted. Fossil fuels must be burned to produce electricity. Burning them creates unwanted products that can create air and water pollution and release large amounts of greenhouse gases into the atmosphere. When in use, solar panels can produce power without waste or emissions and do so through a natural process called photovoltaics. Whether you buy a system and pay it back with the electricity saving, or you pay a low fixed rate for your power through a PPA system, you'll hit the point where your solar panels have paid for themselves. After that, it's real savings for your future. And the bottom line, with utility rates climbing regularly each year, you'll save more with solar than the year before. Fossil fuel deposits are scattered and infinite. Their economic worth and uncertainty are enough to cause disagreements that can lead to labour strikes, police brutality and even war. Solar energy is available nearly everywhere and will be for another 5 billion years. Calculations. Facts and rules. Average family size is 2 to 3 people. Average electricity bill is $500 per quarter. Average electricity used is 2,100 kilowatts of electricity per quarter. One solar panel equals 190 watts. One solar panel is worth around $300. A 5 kilowatt inverter is $2,500. 1,000 watts equals 1 kilowatt. An area of a rectangle is length by width. First of all, we need to figure out the minimum amount of solar panels needed. You do this by doing the average electricity used divided by the electricity of one solar panel. Therefore, that equals 2,100 kilowatts divided by 190 watts. You do the calculations and the answer equals 11. Therefore, we need at least 11 solar panels on the roof to produce the correct amount of power. Next, we need to work out the area of the roof. Area equals length by width. The length of the roof is 9.7 and the width is 1.7. So we sub these in, so you get 9.7 times 1.7, which equals 16.49 meters squared. Next, we need to work out the area of one solar panel. So area equals length times width. We sub in the numbers, so equals 1.6 times 0.8. That gives an answer of 1.28 meters squared. Therefore, the amount of solar panels that can fit on a roof equals 16.49 divided by 1.28, which equals 12.88. Therefore, 12 solar panels can fit on the roof because you can't have 0.88 of a solar panel. Therefore, 12 solar panels will supply enough electricity for the entire family. One solar panel is $300 and a 5 kilowatt inverter is $2,500. The cost of the solar panels will equal 300 by 12 because we have 12 solar panels and each worth $300. So if we do a calculation, the answer is $3,600. We then need to add the inverter to this to find out the total cost. So that is $3,600 plus the inverter, $2,500. After we do the calculation, it works out to be $6,100. These figures are based on the fact that you can install a solar system yourself with no inspection and not including other materials such as brackets. Next, we need to work out the amount of time to get your money back, assuming the solar system was paid for outright and the cost of electricity does not increase over time. To do this, we divide 6,100, the total amount of cost, divided by 500, your average electricity bill per quarter. Per quarter means there's 4 times a year, so then we divide it by 4. So when you sub the numbers in, it gives an answer of 12.2 divided by 4, and you work that out to be 3.05. Therefore, it takes 3 years and 1 month to pay your money back. You will need to use a calculator for this. Just round to 2 decimal places. For this yourself, you would need to work out the angle of the solar panels on the roof. The rule is your latitude times 0.76 plus 3.1. So if we sub our latitude in, Australia, as 35, times 0.76 plus 3.1, you get an answer of 29 points. So this is the total angle that the solar panel needs to be on. However, sometimes the roof is at an angle as well. So assuming the roof is at 20 degrees, we can work it out by 29.7 take 20, which equals 9.7. Therefore, we put the solar power on an angle of 9.7 from the roof. This is the true optimal position for the solar panel to be installed. Solar panels create absolutely no waste or emissions. Unlike fossil fuel power plants, they can produce clean, renewable energy from a fuel source that requires no locating, excavation, transportation or combustion. It's a simpler, cheaper, cleaner and all-round better energy solution.